Welcome to the deep dive. Ever wondered how they figure out the cost of a building before even breaking ground? Today, we're diving headfirst into the fascinating world of pre-construction estimates.
Yeah, it's a really critical part of any project.
Absolutely. If you're involved in any way with bringing projects to life, or even just curious about the nuts and bolts, or should I say, the concrete and steel of construction, this is for you.
For sure. Understanding these early stage cost predictions isn't just about budgets. It's fundamental to shaping the entire vision of a project, setting realistic goals and making smart choices right from the very start.
Okay, let's unpack this then. Today's mission is to get a solid handle on conceptual and design estimates. These are the two main types of financial forecasting that happen before any physical construction kicks off.
Right.
We've got a wealth of information here, everything from those initial kind of can we even afford this, feasibility studies, to more detailed looks at the very systems that make up a building.
And just to set the stage, these aren't the only pre-construction estimates out there. Generally, you'll see sort of three levels. Conceptual, which we're starting with.
Okay.
Then design estimates as things get clearer. And finally, detailed estimates right before construction bids actually go out.
Right. So each one gets progressively more detailed as you know more about the project.
Exactly. Each comes at a different point in the project life cycle with, well, increasing levels of information available.
Got it. And for our deep dive today, we're zeroing in on those crucial early stages, conceptual and design. Now, who are the folks typically pulling these initial numbers together?
Usually it's the project owner and the designers, so the architects and engineers. They take the lead on the conceptual and design estimates.
Makes sense.
Depending on how the project's set up, a construction manager might also jump in at this point to, lend their expertise.
All right, so let's get into the very first step, conceptual estimates, also known as rough order of magnitude or ROM estimates. That name pretty much tells you what to expect, doesn't it?
It really does, a general ballpark.
Yeah.
Conceptual estimates happen right at the very beginning, often during those initial feasibility studies. The big priority here is, well, speed.
Because you don't have much detail yet.
Exactly.
Yeah.
Because the design is still very high level, these estimates can be put together relatively quickly.
And that speed comes with the trade-off, I imagine. Rough order of magnitude. So we're definitely not expecting pinpoint accuracy here.
Not at all. They're inherently rough. Their main job is really as a planning tool,
Okay.
to give the owner a general sense of whether the project is financially feasible and to help kind of nail down the overall scope. It's about answering that core question. Are we even in the right ballpark here?
Okay, so how do you even start to put a ROM estimate together when you don't have a lot of specifics to work with?
Often, it involves looking at the project in terms of key units.
Key units.
Yeah, so if for a hotel, that would probably be the number of rooms. For a hospital, maybe the number of beds.
Mm-hmm.
For an apartment building, the number of individual units.
Ah, okay, so basic measure of size.
Right. Then you multiply that quantity by an estimated cost per unit.
Where does that cost per unit actually come from? Is it just like a guess?
Not quite a guess. An owner who has experience with similar projects might have their own, historical data, their records of past costs.
Okay.
If not, they might consult with professional estimators or use commercially available cost data. A really well-known source is RSMeans.
RSMeans, right. I've heard of them.
Yeah, they compile a vast amount of cost information from, well, a huge range of construction projects.
Okay, let's make this concrete. Let's go back to that hotel example you mentioned.
Sure. So imagine an owner is considering building a 42-room hotel. Based on their prior experience or maybe some initial research using a resource like RSMeans, they estimate that the total construction cost per room, and this wouldn't include the land itself, will be around $84,000.
Okay.
A simple ROM estimate would then be 42 rooms multiplied by $84,000 per room, which gives a total estimated construction cost of $3,528,000.
Okay, $3.5 billion. That gives a general idea, but there must be other big things that can swing that number.
Oh, absolutely. To get a slightly more refined initial estimate, you definitely want to factor in the project's location.
Right. Building in New York is different from building in Omaha.
Exactly. Construction costs can vary quite a bit from one city or region to another. And you might also need to account for potential inflation if the project doesn't, plan to start right away.
But even with those adjustments, there are still a lot of unknowns at this very early stage, aren't there? Big question marks.
That's really a key limitation of conceptual estimates.
Mhm.
You haven't yet addressed the specific architectural design details, the quality of the materials you're going to use, the types of heating and cooling systems, or, say, the planned level of energy efficiency.
And all of those can add up.
Oh, yeah. All these factors can have a major impact on the final cost, but they simply aren't defined in detail this early on.
So even though it's not super precise, what's the really important role of a ROM estimate then? Why bother?
It's about establishing those broad development objectives and the initial financial projections. It helps the owner understand the general financial landscape of the project right at the outset.
Kind of sets the boundaries.
Exactly. And interestingly, this early stage is often where the fundamental character of the project begins to take shape. Does the owner prioritize the size and scope, or the level of quality and finishes, or is the overall budget the absolute main driver? The ROM estimate really forces that crucial conversation early.
And what happens if that initial ROM estimate comes in way higher than the owner was hoping for? Let's say our hotel owner needed to stay under $3 million to get their loan. What are their options then?
They essentially have a few fundamental paths they can consider. First, if the numbers are just too far off, they might have to abandon the project altogether if it just appears financially unviable.
Okay, tough choice.
Second, they could look at reducing the overall size or scope of the hotel, maybe fewer rooms or less extensive amenities to bring that total cost down.
Scale it back.
Third, they could look at reducing the quality of the materials and finishes, using, less expensive options, which would lower the cost per room.
Right, trade-offs.
And quite often, the solution actually involves a combination of scaling back the size and adjusting the quality level.
It sounds like that early ROM estimate, even with its, inherent limitations, really forces some critical strategic decisions right from the get-go.
Exactly. It might not give you the final exact dollar amount, but it provides enough information for the owner to make reasonable initial decisions about how to proceed, or even whether proceeding makes financial sense at all.
Okay, so that's the conceptual level, those initial broad strokes. As the project moves forward and the design starts to become more defined, we move into the realm of design estimates. What changes at this point?
Well, as the design progresses and the architects and engineers start developing actual drawings and specifications, naturally more details become available.
More information to work with.
Right. This increased level of information allows for the development of more accurate cost estimates. Instead of just a cost per unit, like per room, we can start to evaluate different building systems and materials in greater detail.
And I understand there are a couple of key methods that are typically used for these design estimates.
Yes. The two we're going to focus on today are square foot estimating and assemblies estimating.
Okay, let's start with square foot estimating. When in the design process does this usually happen?
Square foot estimating typically comes into play after some initial design work has been done. So you have a general understanding of the building's footprint and layout, the number of floors, things like that.
But not every single nut and bolt decided yet.
Exactly. It's before the entire design is finalized with all the detailed specifications.
And how does it actually work? It sounds pretty, well, self-explanatory from the name.
It is relatively straightforward, yeah. You take the total size of the building, usually measured in square feet, and you multiply it by an estimated cost per square foot. Now, this single cost figure, it's intended to cover all the various expenses involved in construction: labor, equipment, materials, overhead costs, and the contractor's profit. These aren't typically broken down separately at this stage.
So it's more detailed than a ROM estimate because you have more information about the actual size and shape, but it's still kind of a bundled cost.
Precisely. Because you have more defined parameters from the developing design, it offers greater detail and accuracy compared to a ROM estimate. And it's used to further refine the project's budget as the design evolves.
And who usually prepares these square foot estimates? Is it still the owner and designer?
Often, yeah. Or it might be contractors or architects who have experience with similar types of buildings. They might draw on their own records from past projects or, again, utilize published cost data like those RSMeans guides.
Right, the RSMeans data comes up again.
Yeah, they provide average cost per square foot for various building types and, importantly, different quality levels.
Okay, let's dive into a practical problem then. You mentioned an example in our sources about estimating the cost of a house in Tampa, Florida. Lay it on us.
Okay, so the task is to estimate the construction cost of a 1,400 square foot single-story house located in Tampa. The house includes 1.5 bathrooms, a one-car detached garage, and textured ceilings. The exterior walls are planned to be stucco over a wood frame, and the overall quality is considered to be average.
Now, you mentioned quality. The source material highlights that the price of construction is closely linked to the quality of materials and finishes. How does square foot estimating take this into account?
Well, resources like RSMeans categorize residential construction into different quality classes,
Yeah.
typically something like economy, average, custom, and luxury.
Okay.
Each of these classes has sort of typical specifications for various building components. So, for example, the type of roofing shingles specified for an economy house will be different and, less expensive than those for a luxury home. And these varying material choices have different associated costs, which are then reflected in the cost per square foot figures for each class.
And for our Tampa house example, we're aiming for average quality. What does RSMeans typically consider to be an average quality house in their system?
According to RSMeans, an average house in their classifications typically features a simple design, maybe based on standard architectural plans. It usually includes one full bathroom, an asphalt shingle roof, and the base definition doesn't usually include a garage.
Okay.
There might be some slightly distinctive features, and the overall workmanship generally exceeds the minimum building code requirements. Now, our example house has a couple of variations from this base average.
Right, the extra half bath and the garage.
Exactly. The addition of that half bath and the detached garage need to be accounted for.
The source also mentions that the number of stories a house has can affect its pricing per square foot. Why is that? Seems like square footage is square footage.
Well, think about it. A multi-story house, for instance, often requires more complex structural framing, potentially different foundation requirements, maybe more extensive plumbing and electrical runs, compared to a simpler one-story structure.
Ah, okay. More complexity involved.
Right, so RSMeans provides different cost breakdowns based on the number of stories. They'll typically categorize houses as one-story, one-and-a-half-story, two-story, bi-level, tri-level, and so on to account for these design variations.
So for our specific case, a 1,400 square foot, one-story house of average quality, where would we look in the RSMeans data to find that base cost per square foot?
We would need to find the specific RSMeans cost data sheet that's designed for an average one-story house. This sheet typically organizes the costs based on the type of exterior wall system and the overall square footage of the house. For our stucco over wood frame exterior, we'd locate that particular wall system and then find the corresponding cost range for a house around 1,400 square feet. The example in our source material indicates a national average base cost of $119 per square foot for this specific combination.
Okay, $119 a square foot. So the initial base cost for our hypothetical house would be 1,400 square feet multiplied by $119 per square foot. Carry the one that comes out to $166,600.
Correct. But that's just the starting point, right?
Right, because that's the base average house. We still need to factor in the extra features of our Tampa house, the half bath, the garage, the textured ceilings.
Exactly. So that $119 per square foot is for a standard average one-story house.
Yeah.
We now need to add the costs for those specific upgrades or additions. The RSMeans data usually provides typical costs for these as well.
Like line items.
Sort of. A half bath might be listed as adding around, say, $4,167. A one-car detached garage might add around $19,837. And the upgrade to textured ceilings might be listed as an additional cost per square foot of ceiling area, maybe dollars to 60 cents per square foot.
Okay, so for our 1,400 square foot house, that ceiling upgrade would be 60 cents times 1,400, which is $840.
Correct.
So adding those all up, $4,767 for the half bath, $19,847 for the garage, and $840 for the ceilings gives us a total additional cost for the modifications of $25,454.
Yep.
So the total estimated project cost before we even think about location is the base cost of $160,600 plus these modifications of $25,454, which equals $192,054.
That's the estimated cost based on a national average.
Oh, yeah. Right.
Yeah.
National average. But our house is in Tampa, Florida, so now we need that location adjustment.
Exactly. We need to apply a location adjustment. RSMeans and other similar resources publish these things called city location factors. They reflect the relative cost of construction in different geographic areas compared to that national average, which is typically set at 100.
So 100 is the baseline average for the whole country.
Kind of, yeah. For residential construction in Tampa, the location factor given in the example is 0.82.
0.82. So less than 100 or less than 1.0, meaning it's cheaper than the national average.
Correct. It means costs in Tampa are estimated to be about 82% of the national average for this type of construction. And these factors aren't just pulled out of thin air. They reflect things like the local cost of labor, the availability and price of materials, maybe even transportation logistics.
Makes sense. A high factor might mean a booming area with high demand for workers.
Could be, yeah. Or just generally higher wages and material costs.
Mhm.
A low factor might suggest the opposite.
So, to get the estimated cost for Tampa, we multiply our national average estimate of $192,054 by Tampa's location factor of 0.82,
Uh,
which gives us a final estimated cost of $157,484.28. Wow, that's quite a drop from the $192,000 national average.
it is indeed almost $35,000 less. It really highlights how much location can impact overall construction costs. It's a crucial step.
Absolutely. And the source material also gives the comparison for San Francisco.
Yeah, just to illustrate the point further, San Francisco has a much higher residential location factor given as 1.33 in the example.
So, significantly more expensive than the national average.
Right. Applying that 1.33 factor to our $192,054 national average gives an estimated cost in San Francisco of $255,431.82.
Whoa. So the same house costs roughly $157,000 in Tampa and over $255,000 in San Francisco.
According to these estimates, yes. It's a massive difference, nearly $100,000 just based on location.
That really puts things into perspective. It really highlights how crucial it is to go beyond just national averages when you're estimating a real project.
Absolutely essential.
And the final potential adjustment mentioned is for time to account for inflation.
Exactly. If there's going to be a significant time lag between when you prepare the estimate and when construction actually starts, you typically need to factor in anticipated increases in costs.
Right.
You might use general inflation projections or specific historical cost trend data, which sources like RSMeans also provide.
Got it. Okay, we've covered square foot estimating pretty well. Now let's move on to the second key method for design estimates, assemblies estimating. How does this approach differ from what we've just been discussing?
Well, it's different from both ROM and square foot. Unlike ROM estimates, which rely on those broad unit costs for the entire project, like cost per hotel room.
Right.
And unlike square foot estimates, which use an overall cost per square foot for the whole building,
Okay.
assemblies estimating takes a more granular approach. It breaks down the entire building project into its individual building systems or assemblies.
Systems, like the roof, the walls, the floors.
Exactly. Think about the foundation system, the exterior wall systems, the roof system, the interior partitions, the flooring systems, the mechanical systems like HVAC, the electrical systems. Each of these major components is considered and costed out separately.
So instead of pricing the whole building as one big chunk based on its area, you're pricing out the individual major pieces that make up the building.
That's a good way to put it. And while you don't necessarily need complete, final, highly detailed design drawings for every little thing, you do need a general understanding of the size and maybe some key performance parameters for each of these systems.
And this method is generally more accurate than square foot.
Typically, yes. It usually offers a greater level of accuracy, generally considered to be within a range of plus or minus 15% or so.
Okay. What exactly constitutes an assembly in this context? Give us an example.
Sure. An assembly is essentially a grouping of all the individual work items. So the materials and the labor that together form a complete and functional building system.
Okay.
For instance, let's take an exterior stucco wall assembly. It wouldn't just be the cost of the stucco itself. It would include all the necessary components.
Like the studs inside the wall?
Exactly.
Yeah.
Like the 2x4 wood studs, maybe the plywood sheathing behind the stucco, any insulation within the wall cavity, the moisture barrier or sheathing paper, the different coats of stucco finish, and maybe even the paint applied on top. Plus, critically, all the labor required to install each of those components.
Wow, okay, so it bundles everything for that specific system.
Right. You then end up with the total unit cost for that entire wall assembly, often expressed per square foot of wall area, not building area.
And I believe our source mentioned a figure 11.3 as an example of a means assembly's cost data sheet. What kind of information would someone typically find on a sheet like that?
Generally, you'd see a visual representation, maybe a little diagram of the assembly so you can clearly understand what's included.
Helpful.
Then there would usually be a detailed list of all the individual components that make up that assembly, sometimes with their individual unit cost shown. And finally, the sheet would provide a total installed cost for that specific assembly configuration. Often it will also show costs for similar assemblies that might have slight variations in design or material choices.
Like different types of insulation or something.
Exactly. Think of it like a menu where you can see not just the final price for the, say, stucco wall special,
Yeah.
but also a list of the ingredients and maybe prices for variations with different side dishes.
Okay, I like that analogy. The source also mentioned a 12-character identifier or code for these assemblies, like B2010 something something. What's the purpose behind that kind of detailed categorization?
That identifier, yeah, something like B2010 151 2100, is a unique and standardized code. It helps to organize and categorize the just vast amount of cost data involved.
A classification system.
Precisely. The initial part of the code, like B20 in that example, often corresponds to a major division of building construction. Maybe B represents the building envelope, and 20 could be exterior walls.
Okay.
The subsequent characters then allow for increasingly specific breakdowns of the assembly type and its characteristics. So a slight variation of that same wall assembly, maybe using metal lath instead of plywood sheathing, would have a slightly different but related identifier, perhaps B2010 1501 2500.
And this system is consistent across different RSMeans books.
Yes, this consistent coding system is used throughout all of RSMeans' various publications. It acts kind of like a library cataloging system for building components and systems. It allows estimators across different firms, different locations, to basically speak a common cost language.
That seems really useful. And the data also includes a unit of measure, like square feet of wall or linear feet for something else, so you know exactly how to apply the cost to your project quantities.
It sounds like this standardized format really makes it easier to find and compare different systems.
Absolutely. You quickly learn that, exterior walls will always be found under a certain section of the coding system, maybe B2010, roof construction under B2020, interior partitions under C1010, and so on. Assembly's costing essentially takes the individual costs from various construction trades, carpentry, masonry, roofing, painting, etc., and combines them into these broader functional building components.
What would you say is the biggest advantage of using assemblies estimating compared to the square foot method we talked about earlier?
I'd say the flexibility to easily compare the cost implications of choosing different system combinations is a really significant advantage.
Well, for example, you can readily compare the installed cost of one type of roofing system versus another, or evaluate the financial impact of using brick veneer versus stucco for the exterior walls, or look at different types of window systems. It allows for much more informed decision-making during the design process as you're weighing options.
Right, you can swap out assemblies and see the price change.
Exactly.
And when you get a total cost for a specific assembly, say that stucco wall, what exactly is typically included in that final figure from RSMeans?
It generally includes quite a bit: the worker's base hourly pay, any fringe benefits they receive, the installing subcontractor's overhead costs and their profit margin,
Okay.
as well as the general contractor's overhead, profit, and any markups they might apply. So it's intended to be a fairly comprehensive cost for getting that particular assembly built and installed on site.
How does a company like RSMeans even go about gathering all this incredibly detailed data for their assemblies costs? It sounds like a monumental task to keep updated.
It really is. They have a very thorough and, importantly, ongoing process of tracking construction costs across the United States and Canada. They're constantly contacting manufacturers, material suppliers, dealers, and contractors to gather national average material costs.
And that's just materials.
Right. Importantly, those material costs typically exclude sales taxes, which need to be added later. Labor costs are calculated based on average wage rates in about 30 major U.S. cities, and these calculations include not just the base wage, but also typical overhead, profit margins for the labor portion, and allowances for things like worker travel time, setup time, material handling on site.
Wow, lots of factors.
Yeah. They also do extensive research into equipment rental rates and operating costs for things like cranes or excavators. Finally, they identify what are known as general requirements, cost things like site supervision, temporary utilities, permits, insurance, and they present their data usually in two main forms. The bare cost, which is essentially just the direct cost of materials, labor, and equipment, and the total cost, which layers in the contractor's overhead and profit. Understanding that distinction is crucial. Are you looking at the raw expense or the price you're likely to actually pay a contractor?
Definitely.
But it's always, always important to remember that these are averages. The specific conditions, complexity, and features of any individual project will always need to be carefully considered.
So at what point in the design process is assemblies estimating most commonly used? You said square foot was sort of early to mid-design.
Assemblies estimating is typically employed when the design drawings and specifications are somewhere between, say, about 10% and maybe 75% complete.
So a wider range, but still during design development.
Right. At this stage, you generally have enough definition of the various major systems to start pricing them out fairly accurately using this method. And as we mentioned, it generally offers a higher degree of accuracy compared to the broader brushstrokes of square foot estimating because you're focusing on the costs of specific defined building components.
Okay, so just to recap the flow here, we've looked at conceptual or ROM estimates, which are very early, very approximate, kind of feasibility checks.
Right, the ballpark.
Then, as the design develops, design estimates become possible. We looked at two main types: the overall area approach of square foot estimating and the more detailed component-based approach of assemblies estimating.
Correct.
Now, our source material also briefly mentioned a detailed estimate. How does that fit into this progression? Is that the final step before building?
Pretty much. Detailed estimates represent the highest level of accuracy you typically get in pre-construction cost prediction. They're usually developed by the general contractor or perhaps a construction manager when the design is very close to being 100% complete. All the drawings and specifications are finalized. This usually happens just before they submit their actual bid or guaranteed price for the project.
So, much more involved than what we've discussed today.
Oh, absolutely. These are far more complex and time-consuming to prepare. They involve meticulously quantifying and pricing out virtually every single nut, bolt, material item, and labor task involved in the entire construction process. Their accuracy is absolutely critical for the contractor, as this estimate forms the basis of their contract price. Get it wrong, and they could lose a lot of money.
Makes sense. And you mentioned we'll be diving into those detailed estimates on our next deep dive.
That's the plan, yes. We'll explore how those are put together.
Okay, looking forward to that. Before we wrap things up for today, our source material includes a helpful little vocabulary law. It's always good to make sure we're clear on the terms. Assemblies or systems estimating, city location factor, conceptual estimate, design estimate, preliminary estimate, which seems to be another term often used interchangeably with design estimate.
Yeah, you hear that sometimes.
Rough order of magnitude, ROM estimate, the cost data provider, RSMeans, and square foot estimating. It really does all boil down to speaking the same language, doesn't it, when you're talking about costs?
It really does. Precision in language is important here. And, it's worth maybe reflecting on some of the topics for discussion that were raised in the source material.
Definitely.
For instance, what real value does a rough conceptual estimate provide to a project owner, even if it's not precise? Or thinking about those RSMeans figures we discussed, like the unseen figure 11.1, what might be the approximate square foot cost for, say, a 1,200 square foot townhouse with wood siding over a wood frame? And why is that location factor so necessary when using such a figure?
Good questions.
Or, based on another unseen figure, figure 11.2 with the location factors, would building a similar project generally be more expensive in Los Angeles or Washington, D.C., and roughly by how much according to their factors? And maybe think about it from the architect's perspective. What specific advantages might an architect find in using a design estimate that's developed with the assemblies estimating method compared to just a simpler square foot approach?
Definitely some good food for thought there, encouraging you to really apply these concepts. So to quickly summarize our journey today, we've navigated through those initial but really crucial phases of predicting project costs. We started with the broad initial assessment of conceptual, or ROM, estimates, vital for that first financial reality check.
Yep, the go-no-go point often.
And then we moved into the more refined methods used during design. Square foot estimating, based on overall area and quality, and the more granular assemblies estimating, which looks at the cost of individual building systems as the project design becomes increasingly concrete.
And I think the key takeaway for you, the listener, is that these pre-construction estimates, whether conceptual or design-based, are not just abstract numbers on a page. They are truly vital tools.
How so?
Well, they empower project owners to make informed financial decisions. They guide design professionals as they make choices about materials and systems. And they inform construction managers as they plan the work. They provide essential insights into the financial realities of a project and enable smarter decisions every step of the way as that initial idea evolves into a buildable design.
Excellent summary. So here's a final thought to really chew on as we wrap up. We saw just how significantly location can swing building costs. Thinking beyond that, what other factors, maybe things that seem relatively fixed at the outset of a project, could actually have surprisingly variable and substantial impacts on its overall financial feasibility down the road?
Ooh, that's a good one. Or Maybe consider this. If that initial conceptual estimate reveals that a project is likely to be significantly over budget, which of those four main options we discussed, abandoning the project entirely, reducing its size or scope, lowering the quality of materials and finishes, or pursuing some combination, which of those do you think presents the most significant long-term implications for the project's ultimate success, and why?
Lots to think about. Join us next time on the deep dive as we continue to explore the fascinating and complex world of construction and the built environment, diving into those detailed estimates.